What if I told you that the universe you see, the very chair you're sitting on, might not be as real as you think, and that a tiny particle can be in two places at once? Welcome to the bizarre and frankly terrifying world of quantum mechanics. It's a realm where the rules of our everyday world just don't apply, and it's making even the brightest minds on the planet scratch their heads. Let's start with something called superposition. Imagine a spinning coin. Before it lands, it's both heads and tails at the same time. Weird, right? Well, that's what quantum particles do. An electron, for instance, isn't in just one spot. It exists in a cloud of probabilities, a smear of potential locations, all at once. It's only when we try to look at it, to measure its position, that it chooses a single spot to be. This is called the observer effect. The very act of looking at something changes it. Think about that for a second. Is reality only real when we're watching? This idea bothered Einstein so much he famously said, "I like to think the moon is there even if I am not looking at it." But it gets even stranger. Let's talk about quantum entanglement, what Einstein called spooky action at a distance. Imagine you have two particles that are linked, or entangled. No matter how far apart you separate them across the room or across the galaxy, they remain connected. If you measure one particle and find its spin is up, you instantly know the other particle's spin is down, instantly, faster than the speed of light. This seems to violate one of the most fundamental rules of the universe, that nothing can travel faster than light. How do they communicate? We have no idea. It's like they're two sides of the same cosmic coin, forever linked in a mysterious, instantaneous dance. This spooky connection completely baffled scientists and continues to challenge our understanding of space and time. Now, let's dive into the multiverse, or the many worlds interpretation. This theory suggests that every time a quantum measurement is made, every time a particle has to choose a state, the universe splits. That's right, one universe for every single possible outcome. So, in one universe, the electron is here. In another, it's over there. This means there could be an infinite number of parallel universes, an infinite number of yous out there living out every possible choice you could have ever made. A universe where you took that job, another where you missed that train, and another where dinosaurs never went extinct. It's a mind-bending concept that turns reality into an infinitely branching tree of possibilities, and it's a mathematically sound solution to the quantum measurement problem. And finally, there's quantum tunneling. In our world, if you throw a ball at a solid wall, it bounces back. It can't go through. But in the quantum world, particles can. There is a small but real probability that a particle can simply pop out on the other side of a barrier it shouldn't be able to cross. It's like walking through a wall. This phenomenon is not just a theory. It's essential for things like the sun to shine and for modern electronics to work, but the how is still deeply unsettling. It defies our classical intuition about how objects should behave. Superposition, entanglement, many worlds, tunneling. These aren't science fiction. They are experimentally verified aspects of our universe. They show us that reality at its most fundamental level is probabilistic, interconnected in spooky ways, and far, far stranger than we could have ever imagined. It's a reality that's both terrifying and beautiful, a cosmic puzzle that we've only just begun to piece together. What other secrets is the universe hiding? Thanks for watching. If you enjoyed this journey into the quantum unknown, don't forget to like, subscribe, and hit that notification bell for more mind-bending content. See you next time.